Welcome to this information session on the Data Analytics major of Business Engineering. I'm a senior full professor at Ghent University teaching in this elective, who also co-founded this program. In this short video, I want to explain what to expect when pursuing the master degree in Business Engineering, majoring in Data Analytics. We are a team of 3 full-time professors in Data Analytics. Most of you already know Professor Dries Benoit, who teaches the Statistical Modeling and Data Mining course in the second Bachelor of Business Engineering. Professor Matthias Bogaert joined us more recently, and I already introduced myself. Let me start with some quotes that show the importance of data analytics. Here you have an Apple exec stating that data is the biggest differentiator, at least if you make good use of it. This is not just currently the case. McKinsey forecasts that this will continue in the coming decade. We are particularly proud of the fact that we at Ghent University are really a pioneer to offer such a degree, not just in Belgium, but also worldwide. This slide summarizes the 4 ingredients we use. We train you to recognize specific business problems that can be solved with the data analytics methodology. Data scientists should be able to spot opportunities that company internal data offer to solve a particular business problem. But we also train students to consider publicly available data or data that can be bought from other companies. In terms of methodology, we use advanced statistics, data mining, machine learning, and AI techniques. These techniques help to extract knowledge from the data, from the patterns that you can observe, or maybe the predictions that you make for improved decision making. But whenever you make a decision, there is some function that you are trying to optimize. Most commonly, you minimize costs or maximize profits in business. However, you can also use data analytics in non-profit organizations. For example, to maximize charitable donations. So typically, data mining, statistical tools deliver prediction estimates. And these are then put into some optimization model that in the end translates these predictions into optimal decisions. What sets our program apart from the others is our business focus and strong involvement of consulting companies. Moreover, we pride ourselves on providing hands-on experience. We don't just teach the theory, but we also put it into practice. In terms of software tools, the courses are centered around either R or Python. These 2 open source languages are the state-of-the-art every data scientist should be trained in. After 2 years, we expect you not only to be excellent programmers in R and Python, but also to be able to use these tools to solve business problems for improved decision making. In this presentation, I'm going to focus on the 5 courses that are specific to our data analytics major. When making a decision which major to choose, I encourage you to investigate the content of the specific courses. In the first semester of the first master year, we start with a methodological course of data of machine learning in R, taught by Professor Dries Benoit. This course builds on the course of statistical modeling and data mining and teaches you the details of some techniques such as artificial neural networks, decision trees, and random forests, and many more. In the same semester, you will also learn about analytical CRM in Python, taught by myself. Analytical CRM stands for Analytical Customer Relationship Management. In the past, and for small companies, it was a skill of the shop owner to cultivate a relationship with its customers. But nowadays, in big companies, it has become infeasible for one person to keep track of all the likes and desires of its customers. So this skill is offloaded to IT systems and automated programs to optimize decision-making in this domain. In this course, I introduce to you the 4 activities that are typically carried out: customer acquisition, cross-sell or upsell, customer retention, and finally, win back. These 4 activities will be supported by predictions based on company data using statistical or data mining techniques. And we teach you in detail how to perform these tasks. As an example, to make this a bit more concrete, you can think of a recommender system. I'm sure you've all bought something online before, whether that's on Amazon or bol.com or another online vendor. Often, when you look at products, you will get a suggestion recommender system that tells you if you like this product, then you probably also have an interest in these products too. This is what we call recommender systems, and in a course like Analytical CRM, you will see how these systems work, how you can build such a system for your own company or for the company that you work for. In the second semester of the first master, there's the Social Media and Web Analytics course taught by Professor Matthias Bogaert. Nowadays, all companies have a company website. Most companies will be active on social media too. Maybe they have their own app that can be downloaded on the smartphone of customers. And all these new tools allow for much more interactions between customers and the company. Now, all these interactions leave traces. They leave digital traces, and these traces can be relevant and interesting and prove to be valuable for companies to mine in order to try to optimize the business processes. Professor Bogaert will talk about social media analytics, talking specifically about the network, for example, computing centrality measures in networks, the user, for example, event attendance prediction, and the message, using text mining, topic modeling, word embeddings, and so on. Then, in the second master, the first course that I would like to discuss is the course of Big Data taught by yours truly. In this course, Big Data really means a large volume, variety, and velocity of data. One important consequence of this is that the data that is so big that it does not fit on a single computer or server anymore, so that the data handling and storage has to be spread over multiple machines, sometimes even thousands of computers. For example, telecom companies typically operate in this setting. Telecom operators keep track of, for example, CDR data, call detail records, which contain who calls whom, at what point in time, and many more details. This data grows so big so quickly that it cannot be stored on a single machine anymore. Now imagine that you are a data scientist at Proximus or Telenet and you want to do an analysis on these data. You have to know how to deal with such a situation. If you want to calculate a simple mean over the data that is stored on different machines, how do you do that? How do you deal with this situation? Well, there are specialized tools that help us to work with this complex data configuration. These tools are, for example, Hadoop and Spark. And in this big data course, you will get a better insight into how you can use these tools in order to cope with this particular situation. Finally, in the second semester of the second master year, Professor Matthias Bogaert will teach you about predictive and prescriptive analytics. In this course, you will see some more advanced tools for modeling data for improved decision making. But the main focus is on prescriptive analytics. Prescriptive analytics is about analytics that tell us what to do. Predictive analytics is analytics that predict things for us, but in the end, all these tools, all these analytics should help us make better decisions. And this is what prescriptive analytics is all about. That's about how to translate predictions into a decision-making framework. How can we generate optimal decisions from the output of analytical models? So in this course, the focus is really on decision making, on business decision making. Okay, so this completes the overview of the specific courses that you can expect in the degree Data Analytics. Of course, you would like to know where you might end up after graduating with a data analytics degree. I could have shown you dozens of slides here with many different companies, but I'm not sure if that's so helpful. First of all, data analytics skills are highly sought after by consulting companies. And also when you start in this field, being a consultant gives you the opportunity to get in touch with different types of companies in different sectors in a short period of time. So that I think that's what makes it so attractive for the graduates. Know that the real big consulting companies are actively looking for our data analytics graduates. We have many graduates at Bain & Company, McKinsey, or BCG, and many of the smaller consultants. Let's say, so that's the first type of companies that graduates end up with. Secondly, some go to financial services. We have graduates at banks such as KBC, BNP Paribas Fortis, ING, or Belfius. They typically work on a very wide range of topics at financial services. The third group is retail. Think about Colruyt, Delhaize, and so on. These companies have a huge amount of data and they want to keep prices competitive all the time. So prices fluctuate every day too. So they need lots of brain power and data scientists to keep track of all these things and to make it happen. The fourth sector is telecommunications. Currently, there's more than 25 graduates from data analytics at Proximus, just at one company. They have very big data science teams working on their data, translating the data into insights for business, but also creating new products from the data. And then, finally, I would like to mention startups. Many of our graduates start their own company. So they found their own startup company or join an existing startup. If you look in the Ghent area, you will observe that there are quite some initiatives. Good. I hope that this short presentation has given you some insights into what you can expect if you decide to choose data analytics. If you want more information, please visit our website, or if you have specific questions, then don't hesitate to contact us by email. You see the emails shown here. But I think it's always a good idea to also ask some current students what they are following, what they are enrolled in, and ask them about the content of the program, what they think about the courses. It may be true that the data analytics major is not the easiest one. It does involve a fair amount of computer programming in R, Python, PySpark, and SQL. But in the end, many of your predecessors have found it to be worth the effort. If you decide to choose data analytics, please do so because you love to work with data, because you are interested in statistical models and machine learning tools, and you would like to translate these data into insights for business. And if that's your passion, then I'm sure data analytics is the right choice for you.